Good morning, my YouTube viewers. In this particular video, what we're going to talk about is experimental design, and we have a practice question. And the practice question is, test the efficacy and safety of new treatments while ensuring patient safety and ethical considerations. And we're going to answer this question by writing a program in Python. And when we write the program in Python, what we're going to do is we're going to import the libraries that we're going to need to execute the program. So the first library that we're going to import is NumPy as NP, which is a numerical library that also creates NumPy arrays. And then we're going to import Pandas as PD, which is a data processing library that also creates data frames and series. And thirdly, we're going to import matplotlib.pyplot as PLT, which is a visualization library. And from scipy.stats, we're going to import ttest.ind and chi2 contingency. So scipy is Python's scientific library. Stats is a statistical model within scipy. Okay, ttest_ind is a t-test that is performed on two samples that are independent of each other. And chi2 contingency is a test that's used to do a chi-square test. And after we have imported the libraries that we need to import, what we're going to do is we're going to simulate the data that we're going to use in this program. But the first thing that we need to do is we need to set our seed. And the reason why you set your seed is so every time you run the program, the variables will be initialized to the same values. So that means that the program will run the same every time. And you set the seed by typing np.random.seed and any number that you want in between the brackets. So the number of participants in the group is 100. So we're going to simulate the efficacy. That's the improvement score out of 100. So efficacy treatment A equals np.random.normal bracket 70, 10, n participants. So basically what it's going to do, it's going to make a normal distribution that has a mean of 70, a standard deviation of 10, and the number of participants, which is the sample size, is 100. And efficacy treatment B equals np.random.normal bracket 75, 12, n participants. So it's got a mean of 75, a standard deviation of 12, and a sample size of 100. So now we're going to simulate data for safety. So adverse events as 1 is an adverse event and 0 is no event. So adverse treatment A equals np.random.binomial brackets 1, 0.2, n participants. And so a binomial is a binomial distribution, and a binomial distribution has either one of two outputs. So it'll have yes, no, 1, 0, on, off, true, or false. And so it's going to be 20% adverse treatment events for treatment A. And then we have adverse treatment B equals np.binomial brackets 1, 0.25, n participants. So that means 25% adverse events for treatment B. Now we're going to use Pandas to create a data frame of the simulated data that we've just created. So data equals pd.dataframe brackets group is treatment A times n participants plus treatment B times n participants. So you're going to have treatment A 100 times and treatment B 100 times. Efficacy equals np.concatenate square brackets or brackets efficacy treatment A, efficacy treatment B. And then adverse event equals np.concatenate brackets adverse treatment A, comma, adverse treatment B. So now we're going to calculate the mean efficacy and proportion of adverse events. Summary equals data.group by group.agg, that means aggregate. Mean efficacy equals efficacy, comma, mean. STD efficacy equals efficacy, comma, STD. Adverse event rate equals adverse event, comma, mean. So now we're going to perform a t-test for efficacy comparison. T-stat, comma, p-value efficacy equals t-test underscore IND brackets efficacy treatment A, efficacy treatment B. And so your p-value efficiency is a probability, and the t-test underscore IND means that you're going to perform a t-test on data that is not related. So now we perform a chi-square test for adverse events. Contingency table equals pd.crosstab brackets data group, comma, data adverse event. So chi2, comma, p-value safety, comma, underscore equals chi2 contingency table. So now we're going to print the summary statistics and test results. So print summary statistics, and then we're going to print the efficacy comparison t-test. We're going to print the t-statistic and the p-value, and we're going to print the result if. Okay. So what we're going to do, and then we're going to print the safety comparison chi-square test, and then chi-square statistic, and then the p-value, and then we're going to print the result. So we come over here to the bottom of the cell. So the group A statistics are mean efficacy is 68, and for treatment A and 75 for treatment B, 9 for the standard deviation is 9 for treatment A, 11 for treatment B, and adverse event rate is 14% for treatment A and 34 for treatment B. And so now we check the efficacy comparison t-test. The t-statistic is negative 4.316, but the p-value is 0. And so it says significant difference in efficacy. And the reason why is because if the p-value is less than 0.05, you have to reject the null hypothesis. And the null hypothesis is there's no significant difference between the values. And so it had to accept the alternate hypothesis. And the alternate hypothesis is that there is a significant treatment between the values. And then the safety comparison of the chi-square test. The chi-square statistic is 9.896, and the p-value is 0.002. And again, that is less than 0.05, so there is a significant difference between the values. So that means the null hypothesis has to be rejected, and the alternate hypothesis is accepted. So now what we're going to do is we're going to visualize the data with a bar chart for efficacy and adverse events. So plt.figure brackets fig size equals 6,4, and then you've got your plot, your efficacy, plt.subplot brackets 1, 2, 1, plt.bar letting you know it's a bar chart, brackets summary.index, summary mean efficacy, YERR equals summary standard deviation efficacy, color equals blue, orange, alpha equals 0.75, cap size equals 10. So your title is efficacy comparison, the Y label is mean efficacy, and the grid is X equals Y, line style equals dash, alpha equals 0.7. So now we're going to plot the adverse rise in events. PLT dot subplot brackets 1, 2, 2. PLT bar indicating it's a bar chart, brackets summary dot index, comma, summary adverse event rate, comma, color equals blue, comma, orange, comma, alpha equals 0.75. The title is adverse event rates. The Y label is proportion of adverse events. The limit is 0.3. That's your Y lim. And your grid is axis equals Y, comma, line style equals dash, comma, alpha equals 0.7. So we've got PLT.type layout and PLT.show. And so this is the chart that we've made. You've got two bar graphs, one for efficacy comparison and one for adverse event rates. So the treatment A, the mean efficacy score in column B is greater than that of column A, and treatment A, the adverse events rate, is much less than it is for column B. Column B actually, it goes over the chart because it's the adverse events rates for treatment B, I believe, is about 34%, and the chart only goes up to 30. And then so since the bar chart just goes off the chart. So what I would do is, since the adverse events are less in treatment A than treatment B, me personally, I would select treatment A. So that concludes this video. The next video, we're going to be talking about some more experimental design. So I hope that you decide to watch it.